Hi, everybody. These are the notes for 1-2. Any day you're remote, I will have a notes video, which is basically me recording, filling in the notes and talking through them. Or you can always dial in live, just depends on what you want to do that particular day. Might be handy to have your phone and maybe listen to the lecture on your phone while you're filling in the notes on your screen. Or you can always print a copy of the notes using the three little dots in the upper corner. Print the notes and then just write them on paper and watch on your computer. Either way, it doesn't matter to me. Okay, so first thing we're going to talk about is classifying numbers. We have different kinds of numbers. The first one and the biggest group being complex. Complex numbers include both the real and the imaginary numbers. Right now, the only numbers that you've dealt with are real. A little later on this semester, we will start bringing in the imaginary numbers. Imaginary are not real. Examples include the square root of -1, which is the biggest basis of the imaginary number set. The square root of -1 is equal to I. So I is an imaginary number, and anything plus or minus I or any multiple of I is an imaginary number, and any square root of a negative number, like the square root of -9, is also imaginary. Next set we have is the real numbers. The real numbers consist of rational, irrational, integers, whole, and natural numbers. It's the largest set of numbers and includes a lot of different kinds. An example of a real number would be 1/3, -7, square root of 2, pi, 0. Those are all real numbers. They're all the numbers that you're used to dealing with. A rational number is the set Q, any number that can be written in the form of a over b, where a and b are integers and b is not equal to 0. Clearly, b cannot equal 0 because in math we cannot divide by 0. So it's any number that can be written as a fraction. 1/3, -2/7, -6, because you can really think of -6 as -6/1 if you wanted to write it in the form of a over b. It's really any kind of fraction. Rational numbers are the nice numbers. Irrational numbers are any numbers where it will have a decimal, but it doesn't repeat and it doesn't terminate. For example, the square root of 2 is going to give you a decimal that does not have a pattern to it. Pi, 3.14, blah, 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 goes on forever with no pattern or repeating. Something like the square root of 7 would also be an irrational number. Radicals of numbers that aren't so nice. Integers, that's the set Z. Integers are positive and negative whole numbers. -3, 7, -21, 0, 8, numbers like that. But they're both positive and negative. Whole numbers are the natural numbers plus 0. So 0, 1, 2, 3, 4, and so on. No negatives in whole numbers. We use the letter W to represent whole numbers. And then the natural numbers, think when you naturally learned to count when you were little, you started with 1. 1, 2, 3, 4, 5, and so on. So the whole numbers, think there's an O, which is kind of like a 0 for whole numbers. And then the natural numbers, when you naturally learn to count, you did not include the 0. And then integers are positive and negative whole numbers, and we go back up the chain. So if we look at a Venn diagram of this, complex numbers are the set of numbers that includes everything. And then we've got the real in the green box, and then we've got the imaginary. Within the real, so imaginary are square root of a negative numbers, how we end up over there in the imaginary box. The real are pretty much everything else. We've got the rational, nice numbers, irrational, not so nice. The irrationals are the square roots of non-perfect squares. The rationals can be written as fractions. Square roots of nice numbers like the square root of 4 works. Z, the set Z is the integers. Notice I put the little letters out front here for you. Integers, they can be written positive and negative. And then we've got W, which is the whole numbers. And then we've got the natural numbers. So we start with the smallest and we continue to work our way out. Classifying the following numbers. So the square root of 16 is really 4. So what's 4? 4 is a natural number. 4 is a whole number. 4 is an integer. 4 is a rational number. Oops, we use Q for rationals. And it's a real number. And it's a complex number. Once you start inside something, then everything else outside of that continues to work. So negative 17 is an integer. So once I am in an integer, which is z, not I put I over here too, that should be a z. Z, once I know I'm in z, then I can go out to the rationals, go out to the reals, and go out to the complex. So that's integers, then that goes to the, whoops, not writing here, then that goes to the rationals, then that goes to the real and the complex. 32 over 7 is a fraction, so it's not an integer. So we're starting at the rational level, so rational, real, and complex. Square root of negative 12, the square root of a negative makes it imaginary and complex. But we can't use I for imaginary because we use I for irrational. So let's just go ahead and write that out. Imaginary and then complex. Everything is complex. 0 gets you in the whole number category. So then you're out to the integers, the rationals, the reals, and the complex. Negative 14 halves is really negative 7. So that puts you in the integers category because it's negative. It can't be a whole number. So once you're in the integers, then you're in the rationals, you're in the reals, and you're in the complex. And the square root of 7 is an irrational number. So then that puts it into the real category and the complex. Properties of real numbers. For any real numbers A, B, and C, we've got the commutative property, which says we can flip-flop the order. A plus B is the same as B plus A. These rules also work for both addition and multiplication. We could also take A times B equals B times A. Pretty self-explanatory. Pick a couple numbers and try it. You'll see that it works. The associative property is about changing the groupings of things. So we've got A plus B in a group, add on C, that's equal to A, and then if we add the B plus C together first. Same thing with the multiplication. Multiply the first two times the third is the same as if you multiply the second and third times the first. The identity property. The identity property is getting yourself back. Think your own personal identity is you. So if I start with A and I add on 0, I'm back to A again. If I take an A and multiply it by 1, I'm back to A again. The inverse is when you are getting to 0 for addition and 1 for multiplication. So here we're trying to get to 0 or we're trying to get to 1 for the inverse. So for the inverse with addition, it's adding the opposite. And for multiplication, it's the reciprocal. Closure is just a property that basically says if I add up two real numbers, I get another real number. And if I multiply two real numbers, I get another real number. Not really that exciting of a property. I remember using that in lots of proofs in college. But it just says if I add up two reals, I still get a real. Multiply two reals, I end up with a real. And then we've got the distributive property. Doesn't really fall in the addition or multiplication category. Basically, if you've got a constant outside a set of parentheses, you can distribute that A over the addition and you get AB plus AC, or the A could be at the end and multiply it through the other way, BA plus CA. We use the distributive property a lot, and you're probably very familiar with that. So if we needed to name that property, if we look at the first one and we compare both sides of that equation, what we can see is we've distributed here 6 plus the 2x. So that's the distributive property. The next one we look, we've got 3 times 7 equals 7 times 3. So this is about the order. The order has changed. That is the commutative property. And this would be commutative of multiplication, if you want to be technical, because it was the operation of multiplication. If we look at the next one, we've got 6 plus negative 6 equals 0. We're getting to that 0, that is the inverse property. And this would be of addition, because we were adding the inverse in that case. And then if we look at the next one, we can see we've got some parentheses here, and the grouping has changed. The associative is where the grouping changes. So this would be associative of, in this case, addition, because we have addition within the problem. The orders is still the same, 4, 3, 2 equals 4, 3, 2. We've just changed the grouping. The next part, we want to find the additive inverse. So if we go back up here and we remember the inverse section, we are trying to get to 0 or 1. So for the additive inverse, we're trying to get to 0. For the multiplicative inverse, we're trying to get to 1. So if my number is 4, what would I do to add a number to get to 0? I would add negative 4. And what number would I multiply by 4 to get to 1? I would multiply by 1/4. If my number is negative 3, the additive inverse there is 3, because negative 3 plus 3 gets me to 0. And the multiplicative inverse of negative 3 would be negative 1/3, because negative 3 times negative 1/3 gets us to 1. And then we've got 1/7. The additive inverse there would be negative 1/7. So basically you're changing the sign. And then the multiplicative inverse would be 7. 1/7 times 7 gives us 1. So for the additive inverse, we are changing the sign, the positive or negative. And for the multiplicative inverse, we are looking for the reciprocal, but the sign part stays the same. And lastly, using some properties to simplify, and also using our order of operations. Please excuse my dear Aunt Sally. We've heard that numerous times throughout our educational careers. What would we do on the first one? We would distribute the 4. So that'll give us 4x minus 4y. We're going to distribute the 3 plus 6x plus 12y. And then we can combine our like terms. We've got some x's. I've got 4 of them. I've got 6 of them for a total of 10x. And then I can add the y's. Negative 4y plus 12y is 8y. Next one, I've got an a here. I've got an a here. Negative 2a minus 5a, negative 7a. I know I write my a's weird. You'll get used to it. And then I've got some b stuff and some b stuff. 9b minus 7b is 2b. Next one, running out of time. Distribute. We've got 54a minus 18b. Be real careful. We're going to distribute again, but we're distributing that negative as well. Negative 16a minus 32b. Add your a stuff. What's that? 38a. Add your b stuff. Those are both negative minus 50b. And then the last one, distribute. Careful, distribute that negative 6 and let me know what you get. Hopefully after you distributed and cleaned it up, be careful distributing that negative 6, you get negative 74x plus 2z. So go ahead and get started on your homework. Remember, you can find your homework up here at the very beginning of the notes underneath your name. Have a great day. Bye.